Welcome to Multiplying and Dividing Fractions tutorial. With me, Miss Gillum. If you don't know me, I am a 6th grade math teacher in Plano, Texas, but I have also taught 7th and 8th grade math. And if you are my students, I'm so glad you're here and you're watching this video. So let's get started. So first, let's take a look at multiplying a whole number by a fraction. So the first thing I see is that we have 5 wholes. So I'm going to do 5 wholes. So I'm going to take my 5, there we go, boxes that are exactly the same size. And you're multiplying it by 2/3. So you have to think, okay, I'm getting 2/3 of each of these. So I'm cutting them into thirds. I'm sorry for them not being exact. So I get 2/3 of each of these. Then you have to think, okay, well, so that is 1, so let's see how many thirds that is. That is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I could say I have 10 thirds. You can also look at it, well, how many do I need to make a whole? I need 3 to make a whole. So what we can think is, okay, I need 3 to make a whole. So 1, 2, 3, so that is 1 whole. 1, 2, 3, that is another whole. 1, 2, 3, that is the third whole. So I know I have 3 wholes and I have 1 of third left over. This 10 is left over, which I'm sure some of you are already seen. How could I get 10 thirds from 5 and 2/3? So on the next slide, I'm going to show this to you. So in mathematical algorithm, meaning the process of multiplying without the model, we would change the whole number to an improper fraction by putting it over 1. And then we multiply the numerators, 5 times 2, which gives me the 10, and the denominators, 3 times 1, or 1 times 3, which is 3. And then this is an improper fraction, so we need to change it to proper. So remember we talked about how a fraction is just division. So we are going to, how many times will 3 go into 10? It will go in there 3 whole times, and that would be 9. So take 9 away and you have 1/3 left over. Now we are going to take a look at doing 5 divided by 2/3. So notice I have my 5 rectangles again. We're going to also cut these into thirds. So I'm going to try to do a little better job than I did the last time. Okay, this time we are looking at how many 2/3 are in 5. So I'm going to make a tallies. So these are 2/3, so that's one group of 2/3. This is another group of 2/3. 3 groups of 2/3. So I'm just counting 2/3 because they're broken into thirds. This is 4 2/3. Okay. So then I have 5, then these 2 are going to go together and make 6, and these 2 are 7. But if you notice, I left this one off. So I have, right now, I have 7 wholes, but I have 1/3, but the 1/3, how many thirds do I need? I need 2/3. So I actually have half of what I need, because I need 1 more of these to match up to make the 2/3. So that's where the 7.5 comes from. You can also look at it as you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 pieces. So I have 15 pieces, but I'm breaking 15 thirds, but I want to know how many 2/3 there are. So I divide that by 2, and I get the 7.5. Now let's look at this as the mathematical algorithm. So in class, we discovered by doing several examples of the model that I can multiply by the reciprocal. And the reciprocal is the number that we multiply a fraction by to get to a 1 whole. So the reciprocal of 2/3 is 3/2. Notice, we also change division to multiplication. We do not change the first number. This number is not doing the dividing. This number is being divided. That's why it does not change. So then we also need to make this improper, and then we can multiply numerator and numerator, which gives us the 15, and denominator and denominator, which gives us the 15 divided by 2, which we saw in the last slide. And then you just have to think, how many times will 2 go into 15? It will go in there 7 times. That will give me 14, and I will have 1/2 remaining. Now we're going to look at 2/5 times 1/4. So notice I only have one rectangle here because I don't have a whole. 2/5 is not a whole, so I'm going to divide this. Oh, fifths. What am I doing? Okay, sorry. Fifths. Oh, this is my best one yet. There we go. 2/5. And I only have 2 of the 5. But I'm multiplying that by 1/4. So then I have to go the other direction. And this, I only have this section of the 1/4. So that means I have 2 colored in this section, 2 out of the entire, this is broken into 5s, this is broken into 4s, so 5 times 4 gives me the 20. So I only have 2 of the 20. Okay, because remember, when we multiply by a fraction that is less than 1, our answer must be smaller than the original. So to look at this just mathematically, you have 2/5 times 1/4. And we multiply numerator times numerator, which gives me 2. Denominator times denominator, which gives me the 20, which you could simplify down to 1/10 by dividing these by 2/2. Now we're going to take a look at the visual model of how dividing 2/5 by 1/4 actually works out. So the first thing we're going to do is we are going to, once again, break up into fifths, and I'm going to break it the same way I did last time. Sorry that these are not exactly spaced, but you will be okay. So we have 2/5, so I'm going to say I have this and this section. The other one, I'm going to divide into fourths. I'm going to pick a different color for this. So this one will be our fourths, and once again, I did a really bad job. And we have that 1/4. But now we need to merge the two models together. And to merge the two models together is, now I'm going to do my fifths the same way I did on the other one. So I have my fifths, and then I'm going to put my fourths over here, the same direction. So what we are trying to do is determine how many of these do we have in the 2/5 that we see here. So if we look at this, okay, we see we have 1, 2, 3, 4, 5 blocks here. So we're going to count how many blocks do we have. We have 1, 2, 3, 4, 5. So this is a hole that matches this hole. So I know I have one hole. So it's going to be one hole. But then I have these 3 left over here, 3, and I needed 5. So this was our 5, so that would be 1 3/5. So let's look at what this would look like actually mathematically. Okay, now let's look at this via the algorithm by multiplying by the reciprocal. So remember, the 2/5 is not the one doing the dividing. You are dividing the 1/4 into the 2/5. So we're going to multiply by the reciprocal of 1/4, which is 4/1, which gives me 8/5, which actually is 1 3/5 left over. Okay, now that we've done a lot of modeling, I'm going to go straight to the algorithm on these mixed numbers. So this is just multiplying. So first thing we have to do is change these to improper. So we multiply the whole number by the denominator, which will give you 20, and we're going to add it to the numerator because now I know that I have 23/4 in this one. And then I'm going to do the same thing here. I'm going to do 2 times 2, which gives me the 4, plus that 1 is 5. So I have 5 halves. The denominators do not change. So then we are going to multiply straight across. There's nothing I can do to simplify yet. So then I have 8. If we don't know what 23 times 5 is, come off to the side, work it out if you need to. This will give you 15. 10, 11. So this is 115. But this is an improper fraction. We cannot leave it improper. So we must change it to a mixed number. So I have to think, how many times will 8 go into 115? So we might need to write our long division out. 8 goes into 11 one time with 3 left over, and then 8 goes into 35 4 times with 3 left over. So it'll go in there 14 times with 3/8 left over. So we change mixed. So let's go over this. We change this mixed to the impropers by multiplying the denominator and adding the numerator. And then we had to change this improper back to a mixed by dividing. Now let's look at the difference between what this looks like if I was actually dividing the two same numbers that we just did. So once again, we're still going to change these to improper. So we already learned that this is 23/4. 5 times 4 is 20, plus the 3 is 23. And then this is going to be 2 times 2 is 4, plus the 1 is the 5. So this is 5 halves. I'm going to write it here for a second. But we've learned that we can change the multiplication and multiply it by the reciprocal, which is 2/5. And now we can multiply straight across and we get 20. And then 23 times 2 will be 46. And I can see that 20 will go in there 2 times, which gives me 40. And I have 6/20. And you can simplify that because 2 will go into both of them. So that would be 2 3/10 would be your final answer if you needed to simplify. You should be able to look at these problems, these two, and determine 2.5 should go at least 2 times into 5 because 2 times 2 is 4 and I have 5 here. So you can always stop and think, does my answer make sense? I hope this video helped and clarified any misunderstandings. If you still have any questions, feel free to write me on the Google Classroom or a comment on here about a certain type of problem you'd like to see, and I can make a video for that. Have a great night. See you in the morning.